The last class we have seen the solar radiation spectrum, like how it is reaching the atmosphere with what energy, as well as how it is reaching the sea level, and what are the various absorption bands of H2O, CO2, oxygen, as well as ozone and all. Right. Okay, now we will see what is this solar radiation concept and how it is going to be reflected or emitted and all those things. So if you see, there is extraterrestrial solar radiation. Okay, the one which is reaching the atmosphere, Earth's atmosphere. You can see that in this, what is this shape? Circle, semicircle, right? So if you consider that boundary as atmosphere, the one which is reaching on the boundary is known as extraterrestrial solar radiation. Okay, fine. Now if it directly reaches the inclined surface of the panel, let us say our solar panel is inclined with some angle to the surface, right? So if it directly reaches the panel, it is known as direct radiation, right, without any reflections and all. Suppose if the one which is reaching the atmosphere is reaching the inclined surface or solar panel through reflection, it is called indirect radiation. Okay, so it is a part of direct as well as indirect radiation. So if you read it here, the sunlight has two components, that is direct beam and diffuse beam. This diffuse beam is the one which is coming through reflection or indirect. So solar radiation received on the earth's surface without change in direction is called beam or direct radiation. So if we are even having a different name for direct radiation, that is beam radiation. Okay, then what is diffuse radiation? The diffuse radiation is that solar radiation which is received from the sun after its direction has been changed by reflection as well as scattering by the atmosphere, right? So this is nothing but indirect as well as known as diffuse. So the total solar radiation received at any point on Earth's surface or sea level is sum of the direct as well as diffuse radiation. Very important point. Okay, that's it. It is very simple. Okay, if you remember this diagram, you can write all these things. Perfect. Okay, next. So now let us see the working of solar photovoltaic. So we all know there is a panel which is made up of different arrays, and arrays are made up of modules, and modules are made up of cells. These all are solar arrays terminologies. So how solar array is made up of? Array is made up of modules, modules are made up of cell. So solar cell is the basic component of solar photovoltaic panel, right? So let us see. A solar PV cell converts the energy of light directly into electricity by the photovoltaic effect. We will see what is photovoltaic effect next. And this PV or solar modules are framed in series and in parallel to form a PV or solar array. Okay, so there are different modules. If the modules are connected in solar or parallel, it becomes an array. So the PV array is a combination of PV modules in series and parallel. That's it. So the number of series modules increase the voltage rating, whereas the number of parallel modules increase the current rating. Okay, so each module might be having one voltage rating and current rating. If you connect the modules in series, the entire array's voltage rating will be changing or increasing. If you connect the modules in parallel, the current rating will be increasing. As per the requirement of the design, we need to connect the modules either in series or parallel, right? Okay, then what is this photovoltaic effect? This is the main principle of solar power generation or energy generation. So if you see here, this photovoltaic effect was first discovered in 1839 by Edmond Becquerel, and solar cells are composed of two different types of semiconductors, that is p-type and n-type, which are joined together to create a p-n junction. So this p-n junction is the main thing which is used for the production of solar energy from the light energy. So what happens here with respect to p-n junction, we will see. So when a photon of light with sufficient energy strikes n-type silicon, so if you see here in this figure, there is n-type silicon material and p-type silicon material which are joined together, right, and formed as a p-n junction. And when sunlight falls on the n-type silicon, what happens? The electron hole pairs of the depletion region will be moved. So in general, there will be a depletion region when p-n junction is formed by stacking n and p materials. So only when this depletion region is completely got removed, then only the electricity can flow through the p-n junction. So for that purpose it requires certain energy, and that energy is coming in case of solar PV cell from the sunlight. Okay, that is what mentioned here. So the electron hole pairs of the depletion region will be moved only when photon of light with sufficient energy hits or strikes the n-type silicon. Okay, and the electrons move towards n-type and holes move towards p-type. What are these holes? Holes are the one which are having positive charge, and electrons are the one which are having negative charge. This is from the physics concept. Okay, so when they are moving, we are getting current. So current is nothing but rate of charge, right? So in this way a potential difference will be created across the solar panel, and whenever there is a potential or voltage, if you connect any load, the current will be flowing. So load means a closed path. So if you see here, a load is connected which is considered as a lamp here, through p and n types it is closed, and the voltage that got appeared across the p-n junction will be giving rise to the current flowing through the load, right? So this is what the working principle of solar PV array are, which is nothing but photovoltaic effect, right? Okay, let us see the solar PV cell. What is the basic component of solar array? That is PV cell, and this cell is the one which produces a voltage of 0.57 volts only. Okay, but if you want to get some 10 volts, we should be connecting various solar cells in series, right? That's how solar array can be made up of, right? So when the sunlight shines upon it under open conditions, it will be producing a voltage of 0.57 volts, and this voltage would be same regardless of how big the size of the cell is, but its current supply is directly proportional to its surface area, right? The surface area decides the current rating. In that sense, a solar cell can be considered a constant current source as well as a voltage source, because it is depending on the surface area. That's it. Once the solar cell is designed, its area is fixed, so its current rating as well as voltage rating will be fixed. Okay, and the solar cell is a non-linear device, and its performance is subject to its characteristic curve. We will see what is this characteristic curve and how it is going to give you the power. Fine, right? So these types of photovoltaic cells we will be seeing next, right? Thank you.